Good evening, Ramam Shashlagal, what I will feel connected with. How are you guys? This class is for CBSE students for 10th class. Okay, some of you have commented in comment section that I should make a video, separate video for CBSE students. So this class is going to be for CBSE student, and today we will discuss 8th chapter, and in which we'll see some questions of proof. Okay, and the very first question, before solving any questions, you must go through three identities. Okay, and the rest of result what we can derive from these three identities. Like the very first identity is sin square theta plus cos square theta is 1. Okay, so we can also derive two results from this identity, and the very first result, if I put this sign here, so it will be sin square theta, and transposition this cos square theta in another side, then it will be 1 minus cos square theta. Okay, so according to the question, whenever I will I'll need sin square theta, I can use 1 minus cos square theta, and if somewhere is given 1 minus cos square theta, instead of this one I can use sin square theta. Okay, and likewise, if you put cos square theta in this side and transposition this sin square theta in another side, then it will be 1 minus sin square theta. Okay, so from first identity, these two results you have to also remember. Okay, and the second identity is 1 plus tan square theta equal to sec square theta. Okay, and if you transposition this tan square theta in another side, then it will be 1 equal to sec square theta minus tan square theta. So if you will need somewhere it is written sec square theta minus tan square theta, then we'll use 1 instead of that. Okay, and if you put 1 here, and no, if you put tan square here and transpose this 1 in another side, then it will be sec square theta minus 1. Okay, so these are some results which we can also derive from these identities. And third identity is 1 plus cot square theta equal to cosec square theta. Similarly, if I transpose this cot square theta in another side, then it will be cosec square theta minus cot square theta. Okay, and if I transpose this 1 from this side to another side, then it will be cot square theta equal to cosec square theta minus 1. So basically you have to remember these three identities. After that you can use these three identities if you will need this. Okay, so let's start from the very first question, and that is given. You have to prove we will solve some 50 to 60 examples, so that it will make a basic understanding so how to solve these examples. The very first example is, you can also see on the screen the very first example, the 1 minus sin square theta equal to multiply, sorry, here it is sec square theta equal to 1. Okay, so you have to prove this one. So I'll take left hand side is 1 minus sin square theta and equal to multiply sec square theta. So we have just discussed I can use 1 minus sin square theta as cos square theta, so I'll put cos square theta, and this sec square theta I'll use 1 upon cos theta, because okay, three another things which you have to remember. Cosec theta, wherever there will be cosec theta, we'll use 1 upon sin theta. Where there will be sec theta, we will use 1 upon cos theta. Okay, wherever there will be tan theta, we'll use sin theta upon cos theta. Okay, and if it is cot theta, then we will use cos theta upon sin theta. Okay, and there is also one relation between tan and cot. If it is given like a cot theta, we can use 1 upon tan theta. Okay, so these are basic things which you must know, and I hope you know already. So it will be cos square theta, and this will be 1 upon cos square theta. So cos square will cancel cos square, and we'll get our first answer. That it was very easy question. Let's move to the next question. This was the first question, and first of first, and second of first is 1 upon 1 plus sin theta plus 1 upon 1 minus sin theta, and you have to prove this as to sec square theta. Okay, so before solving these examples, you must carry one thing in your mind, that first of all you will convert all other trigonometry ratios in sine and cos. Okay, wherever it will be given like cosec theta, you will use 1 upon sin theta, sec theta will be 1 upon cos theta, tan theta will be sin theta upon cos theta. Okay, first of all you will convert all other trigonometry ratio in basic ratios, and those are sin theta and cos theta. But here already it is given sin theta, and here it is also sin theta, so we don't have to do anything, just simplify this and we'll get this answer. Okay, so by taking left hand side, that is 1 upon 1 plus sin theta plus 1 upon 1 minus sin theta. Okay, so whenever you have two identities like two numbers like this, taking example, just like if it is given 2 by 3 plus 1 by 4, okay, simply you don't have to do anything, just multiply this 4 by this 2, so 4 2s are 8, and put a sign between this plus, okay, and 3 1 ja 3, multiply this number by this number, so it will be 3. And in denominator, as a denominator, you will use multiplication of both of denominators. Okay, so denominator here is 3 and here it is 4, so 3 4s are 12, so answer will be 11 upon 12. Similarly, you have to follow this way to solve this example. So if I multiply 1 by 1 minus sin theta, then it will be 1 minus sin theta. Okay, 1 plus sin theta will be multiplied by 1, then it will be 1 plus sin theta. Okay, and here both of these will be multiplied by, okay, so 1 plus sin theta is multiplied by 1 minus sin theta. Now you have to go through one identity, a plus b into a minus b, that is a square minus b square. Here sin will be cancelled by sin, so here we will have 2, and we'll apply the identity a plus b into a minus b, that is a square minus b square. So here it will be 1 minus sin square theta, 1 square minus sin square, 1 square is 1 and 1 minus sin square, that is cos square. So it will be 2 upon cos square theta, and 2 upon cos square theta, 1 upon cos square theta, we can use 1 upon cos theta as sec theta, so it will be 2 sec square theta. So it was our second question. Let's move to next example, and that is cos square theta plus 1 upon 1 plus cot square theta. You have to prove this one, as this is third example. Okay, so sometimes there'll be simply direct identity, which we can see here, 1 plus cot square theta. Okay, so you'll use that identity. 1 plus cot square theta is I'll take left hand side, the first one is cos square theta. 1 upon 1 plus cot square theta, 1 plus cot square theta is cosec square theta, so it will be cosec square theta, and here it is cos square theta. 1 upon cosec square theta is sin square theta, and sin square plus cos square is 1, and that is right hand side. We have to prove this. Okay, so it was third question, and first is, okay, some of question we have missed. Okay, so we'll solve this here. This is cos square theta 1 plus tan square theta, and you have to prove this one. Okay, so taking left hand side, this is cos square theta. These are very basic examples to make a basic understanding of how to solve the questions. Okay, so cos square theta, and instead of 1 plus tan square theta, this is direct trigonometry identity, so you can use sec square theta instead of 1 plus tan square theta, so it will be sec square theta, and it is cos square theta, sec square theta 1 upon cos square theta, and cos square theta will be cancelled by cos square theta, and that will be 1. Okay, and we have to prove that right hand side. So these questions will not be asked in your exam definitely, but to make a basic understanding, first of all we'll solve like mostly 10 to 9 to 10 examples like this. Okay, so question number 5, that is cosec square theta plus sec square theta. You have to do cosec square theta into sec square theta. Okay, so first of all I'll take left hand side, cosec square theta. I'll use cosec square theta as 1 upon sin square theta, and it will be 1 upon cos square theta. Okay, now we have earlier discussed how to solve this one. You'll simply multiply cos square theta by 1, then it will be cos square theta. I'll put this sign, and sin square theta will be multiplied by sin square theta, so it will be sin square theta. Okay, and both of these will be multiplied by each other, so it will be sin square theta into cos square theta. Okay, now we know sin square theta plus cos square theta is 1, so it will be 1 upon sin square theta cos square theta. 1 upon sin square theta is cosec square theta, and 1 upon cos square theta is sec square theta, and you have to prove this one. Okay, so this is a right hand side. Sixth example is, there is nothing to understand in this. Okay, you have to just remember some basic things, and after solving this you'll get right hand side. Okay, so next question is under root sec square theta plus cosec square theta, and you have to prove that tan theta plus cot theta. Now simply you can see here there is under root. Okay, so it will be omitted by some method, and we'll get a quantity without under root. Okay, so we have here there is a quantity without under root. Okay, so first of all just follow simple steps. First of all you will convert sec square and cosec square in sin and cos. Okay, so simply I'll write 1 upon cos square theta, and instead of this one 1 upon sin square theta. Okay, now solve this. This is the very question we have discussed this one. Okay, so it is sin square theta plus cos square theta, and in upon we will have sin square theta and cos square theta. Okay, sin square plus cos square, that will be 1, and this one will be sin square theta and cos square theta. Okay, so root 1 is 1. Okay, this is sin square theta, and under root is given, so sin square theta will be cancelled by square will be cancelled by under root, so we'll have only sin theta here, and similarly we'll have cos theta. Now you have to prove this one. Okay, so take this one as right hand side, you will use sine square is 1. Okay, so it will use sine square theta plus cos square theta upon sine theta into cos theta. Okay, now simply we can use now, instead of 1 we can write sine square theta plus cos square theta. Okay, now simply you'll just divide in both of these numbers. So sine square theta will be divided by sine theta and cos theta, plus cos square theta will be divided by sine theta and cos theta. So one power of sine will be cancelled, so here we'll have sine theta as numerator, and denominator we have cos theta. So cos, one power of cos will be cancelled, so cos theta upon sine theta. So this will be tan theta and this will be cot theta. Okay, so this was the question. And next question is, we have fifth question, sorry, it is seventh question, sixth or seventh question. That is 4 power of sine theta minus 4 power of cos theta plus 1 and multiplied by cosec square theta, and you have to prove this as 2. Okay, so by taking left hand side, now you'll see here nothing is like in other trigonometry ratio already there are sine theta and cos theta. Okay, so simply first of like 5 identities you must remember, and the very first one is a plus b its whole square, second one is a minus b its whole square, a plus b whole square is a square plus b square plus 2ab, and a minus b whole square is a square plus b square minus 2ab. These two identities, and similarly these two identities also, a cube plus b cube, instead of a cube plus b cube we can write a plus b into a square plus b square minus ab. Okay, and a cube minus b cube, instead of this one we can write a minus b a square plus b square, and here I'll use plus ab. Okay, so these two identities, and the very last one and very important, that is a plus b into a minus b. Okay, so this is the identity of a square minus b square. Okay, so if you remember these 4 identities, there'll be no questions, no question will be left. Okay, so I'll use this identity in this one. Okay, and that is sine to the power 4 and cos to the power 4 plus 1, and here it is cosec square theta, and this is left hand side. So can I write down sine raised to the power like this one, sine square theta and its square. Okay, because power to the power will be multiplied and it will get sine to the power 4. Okay, similarly I can write down cos square theta and its power 2, and we'll put 1 here. Okay, and this is cosec square theta. Okay, now I'll use this identity a square minus b square. Instead of this one, can I write down sine square theta plus cos square theta into sine square theta minus cos square theta and plus 1. Okay, instead of this one I have wrote this by using this identity a square minus b square, a plus b, a minus b, and this one is here, and we have cosec square theta. Okay, sine square theta plus cos square theta, we'll use 1. Okay, and will be left with sine square theta minus cos square theta plus 1. Here it is. Now you can see 1 minus cos square theta. 1 minus cos square theta is sine square theta. So sine square theta plus sine square theta, and here we have cosec square theta. Sine square plus sine square, you got now 1 minus cos square, this will be sine square, and we have sine square, so this will be 2 sine square theta, and simply I'll convert this in sine, so it will be 1 minus sine square theta. Sine square theta will be cancelled and we'll get 2. Okay, and we have to prove this one. So this is right hand side. Okay, so these are most important identities, you have to remember this because we'll apply these identities in another questions. Okay, and so it was the last 7th number question. The very first example I will use second example number 2, and similarly we have some 4 questions in this example. The very first question is cot square theta minus 1 upon sine square theta equal to minus 1. Okay, you have to prove this one. So cot square theta, left hand side, this will be minus cosec square theta 1 upon sine square theta. Okay, now we know what we know. We know that 1 plus cot square theta equal to cosec square theta. Okay, so instead of cosec square theta I can use 1 plus cot square theta, so it will be cot square theta minus, instead of cosec square theta I'll use 1 plus cot square theta, so it will be cot square theta if we have minus, okay, if we have minus, so the sign of all these identities, all these numbers will be changed. Okay, so it will be minus, and it will be minus cot square theta. Cot square theta will be cancelled, and we'll left with a minus 1. So this was question number first of example. Second, let's take another example. Similarly, we have tan square theta minus 1 upon cos square theta, and you have to prove this as minus 1. So the very method we'll use in this example, let me see. Okay, so taking left hand side, that is tan square theta minus 1 upon cos square theta is sec square theta. Okay, and instead of sec square theta, instead of tan sec square theta, I can use 1 plus tan square theta. Okay, so it will be tan square theta minus 1 and minus tan square theta. So tan square theta will be cancelled, and we'll left with minus 1, and you have to prove this. Third question is 1 plus tan square theta, 1 plus tan square theta, 1 plus sin theta, 1 minus sin theta, and you have to prove this as 1. So now you can see 1 plus tan square theta is direct identity, which is second identity, and instead of this one I can use sec square theta, and this is a plus b into a minus b, so it will be 1 a square minus b square. So this will be 1 upon cos square theta, and 1 square of 1 will be 1, so 1 minus sin square theta, I'll use cos square theta. Cos square theta will be cancelled, and we'll get 1, and you have to prove this one. So it is right hand side. The fourth question is similarly 1 plus is given 1 plus cot square theta, 1 plus cos theta, 1 minus cos theta, and you have to prove this as 1. Okay, 1 plus cot square theta, that is cosec square theta, 1 plus cos theta, 1 minus cos theta, a plus b, a minus b, so it will be a square minus b square. This is left hand side. Instead of cosec square, I'll use this 1 upon sin square, and 1 square of 1 is 1, 1 minus cos square, and 1 minus cos square is sin square theta. Sin square will be cancelled by sin square, and we're left with a 1. Okay, it was question number 4, and it was example number 2. And let's move to next question, and that is question number 3. And the very first question of question number 3, that is sin theta upon 1 minus cos theta, and we have to prove cosec theta plus cot theta. Now you can see there are two terms in right hand side, and we have only one single term in left hand side. So how will use rationalization? We'll use rationalization here. So left hand side we have sin theta upon 1 minus cos theta, so I'll rationalize this denominator, so I'll use opposite sign. Okay, you have already discussed rationalization in first, I think first chapter. So it is 1 plus cos theta, I'll multiply 1 plus cos theta by denominator and numerator. Okay, so it will be 1 plus cos theta, and here it will also have 1 plus cos theta. I can multiply with same number both denominator and numerator. Okay, so it will be sin theta 1 plus cos theta, and this is a minus b, a plus b, again it is a square minus b square, so 1 square minus cos square theta. So it will be sin theta 1 plus cos theta. So 1 minus cos square is sin square. 1 power of sin square will be cancelled, and we'll left with 1 plus cos theta upon sin theta. Now simply I'll divide each of these terms by sin square theta. So it will be 1 upon sin theta plus cos theta upon sin theta. 1 upon sin theta we have cosec theta, and cos theta upon sin theta we have cot theta. So this is the very terms which we have to prove. Okay, so this is right hand side. Okay, moving to the next question, that is question number 2 of 3rd, and what it is given tan theta plus sin theta upon tan theta minus sin theta, and you have to prove this as sec theta plus 1 upon sec theta minus 1. Now the observation is most important in these questions, these type of questions, like which method we will use here. Okay, so you can see there are two terms here, we have also two terms, there are two terms in denominator, there are also two terms in denominator in right hand side, and same signs are there. It is plus sign in numerator, here we have also plus sign in numerator. Now you have to make some changes, like don't measure changes, just you have to bring one here. Okay, so this is tan theta plus sin theta upon tan theta minus sin theta. As left hand side, simply I will instead of tan theta, I can use sin theta upon cos theta plus sin theta upon 1 this is numerator, and in denominator we have sin theta upon cos theta minus sin theta. Okay, so I'll take sin theta common from this. So if I take sin theta common, it will be 1 upon cos theta plus 1, and by taking sin theta common from here, I'll have 1 upon cos theta minus 1. Okay, sin theta will be cancelled, and 1 upon cos theta, that is sec theta plus 1, and here it is sec theta minus 1, and we have to prove this. This is right hand side. Moving to the next question, that is question number 3. It is cot theta minus tan theta, and you have to prove this cos square theta minus 1 and sin theta and cos theta. Now you can see there are there is some numerator and denominator. So by solving this, because if we convert these cot theta and tan theta in sin theta and cos theta, we'll get this one. Okay, so by taking left hand side, that is cot theta minus tan theta. Cot theta is, very good, cos theta upon sin theta, and tan theta is sin theta upon cos theta. Okay, so we'll use the same method we have discussed earlier. So cos theta into cos theta, that is cos square theta, minus sin theta into sin theta, that is sin square theta, and sin theta cos theta. We have the same denominator as we have to prove in right hand side. Okay, now you have to convert this. We don't need sin square theta. Here we'll have only cos square theta. So I'll omit this sin square theta by using 1 minus cos square theta. I can use 1 minus cos square theta instead of sin square theta. So this is sin theta into cos theta. Now simplify, solve this. So it will be minus 1 plus cos square theta upon sin theta into cos theta. Cos square plus cos square, that will be 2 cos square theta minus 1 upon sin theta into cos theta, and this is the very term we have to do. Okay, so this is right hand side. It was question number 3, and next we have fourth one. Now pause the video and solve this at your own, and we have to prove 2 sin square theta minus 1 upon sin theta into cos theta. Okay, we'll use the same method as we have discussed right now. So we'll take left hand side, and that is tan theta minus cot theta. I'll convert tan theta and cot theta in sin theta and cos theta. So instead of tan theta, I can write down sin theta upon cos theta, minus it will be cos theta upon sin theta. So sin theta will be multiplied by sin theta, then it will be sin square theta. Cos theta will be multiplied by cos theta, then it will be cos square theta, and as a denominator we'll have sin theta into cos theta. So I don't need cos square here. Okay, so instead of cos square, I can use 1 minus sin square. Okay, so I'll use 1 minus sin square instead of cos square, so it will be 1 minus sin square, and as a denominator we have same quantity as sin theta into cos theta, so it will be sin theta into cos theta. So it is sin square theta, and here we have minus sign, okay, outside of this bracket. So all signs of quantities inside the bracket will be changed, so it will be minus 1, and this minus will be plus sin square theta. Okay, and as a denominator we have sin theta cos theta. Sin square plus sin square, that will be 2 sin square theta and minus 1 upon sin theta into cos theta. Okay, and this is the very quantity we have to prove. So these were some questions, 4 questions here, and earlier we have discussed 7 questions. So